Dr. Nikolai, welcome again. Good evening in your part of the world. So, straight away moving to the discussion from where we left off last time, that you discussed your entry, your motivation in this field of vaccinology or immunology, and you discussed the return or comeback of alum adjuvants. And I just wanted to build on it further by asking you that what is the ultimate determination that is being made in the choice of the vaccination platform or the route of vaccination? I was just wondering that if it is like different cars, different technologies, each car has its own used its own capacity to drive in in a terrain 4x4 versus street cars, sedans. So is the vaccine technology and its platforms and its routes of inhalation determined by several factors, sir?
So the ultimate objective of vaccination is always the same. It's to induce a protective immune response, memory immune response that will be able to protect us if we get exposed to the particular pathogen or other stimulus that is causing the problem. So it's really teaching, or educating the immune system. That's what vaccines are doing. And there's no evidence that doing that, educating the immune system to recognize a particular protein or molecule is harmful. So at its essence, the vaccination should be completely safe. Of course, the technology, vaccination is not the technology, so vaccination is the outcome. Uh, in other words, air travel is incredibly safe, but is every plane safe? Of course not. Some planes are safer than other planes. Some planes get taken out of operation. And we've seen the example, I guess, of the Boeing recent Boeing Max jets that had a fatal flaw. They were driving themselves into the ground, and I think most people don't want to fly on those planes anymore. But flying itself is extremely safe. There's one death per, I think, 3 million passenger miles, or, much lower risk than driving a car. So we have the same situation with vaccines, that the concept of vaccination and the outcome of vaccination, inducing an immune memory response is inherently completely safe. But that isn't to say that some of the technologies that have been used to attempt vaccination haven't proved to have significant side effects or safety issues. And so this is I guess the dilemma for the vaccine industry. Same as it is for the airline industry. Should we talk about the planes that weren't safe and had to be discontinued, or do we just tell people how inherently safe air travel is and not focus on the different technologies? Because when you focus on different technologies, it's very clear to the insiders. There's some planes that they would choose to fly on, and there's probably some that they'd say, no way am I getting on that particular aircraft. I know it's not as safe as the other ones. And so I think inside the vaccine world, we know that applies equally to different vaccine technologies. The question is, should that be discussed in public? The fact that some vaccine technologies are inherently a lot safer than other ones. The safest technology of all, I would say, is, recombinant protein-based vaccines, which is the technology I've chosen to work on for that reason, that really it's very hard to show where it hasn't been completely safe. But if we talk about other technologies like live virus vaccines, some of the newer technologies, some of the ingredients that put in vaccines, no, I couldn't put my hand on my heart and tell you that some of those things may not have inherent problems that occasionally may cause serious side effects. And so it's really a question of to what extent are we free to even discuss these issues, just as are we free to discuss which planes I would suggest or which airlines would I suggest you shouldn't be flying on, because their safety record is so much worse than other airlines like Qantas, which I think still to this day is the safest airline in the world over 100 years in terms of never having actually lost anyone to a major accident, despite such a long history. There must be something they're doing that's right. So I think on Rain Man, Dustin Hoffman, who was playing the autistic character, told his brother that the only airline he was prepared to fly in the world was Qantas. And the brother says, well, they don't even fly to the US. And he said, but they're the only airline that never has had a crash that's resulted in loss of life. There are other airlines, again, I don't want to label some countries or their airlines, but seriously, yeah, I mean, it's not that every plane crashes, but they have far more, accidents and loss of life than Qantas. So, but they're all quite safe, like, because air travel, as I say, even getting on an unsafe, what I might call an unsafe airline, the chances are you'll still get to your destination, because overall, the airline industry is exceptionally safe. So even the worst, and I think vaccines, we're sort of dealing with something very similar, where overall they're exceptionally safe. But are they all equally safe? No. And that again is a nuance that I think needs to be better communicated out there, to explain when we're having these arguments. It's not saying something is terribly unsafe. It's just saying relatively it's not as safe as. But doesn't mean both of them aren't relatively safe. It's just one safer than the other. It's like taking, say, the 10 fastest 100-meter runners in the world and saying the 10th guy is not as fast. It's not saying he's slow. He does the 100 meters in 9.95 and Usain Bolt can do it in like 9.7. Am I calling that guy who's the 10th fastest runner a slow runner? No, you know what I mean? But I'm saying he's definitely not the fastest. So that's a similar comparison. When I say a vaccine isn't as safe as, say, my protein-based vaccine, I'm not saying it's unsafe. I'm just saying if I had a choice, just like if I was betting on a race, I'd prefer to bet on Usain Bolt than someone who's 0.001 seconds slower. But they're both fast, yeah. So that's where it's difficult having these conversations, because whatever I say, I have to preface by saying vaccines are exceptionally safe.
Dr. Petrovsky, remarkable analogy of the runner, because in one season, if runner A is doing great, then somebody who qualified or who ended up at position 10 in a given season has equal chance to improve upon in times to come. So this safety culture and this fitness culture is so dynamic that there is no permanence at the top. And you just like touched upon such a something, having been doing some of the randomized control trial, phase 3 control trial. So the process starts right from your first visit to the site to the end if the product is good, it gets approved. And in between, there are like hundreds of different aspects that need to be satisfied all the times. It's because it's a matter of vaccine safety, or as you said, that it's a matter of being a champion runner. There is no free day, no off day in life of a professional runner, professional
No,
runner
no, and unfortunately, that's very true as a vaccine developer,
as a
as you
vaccine.
say. Like, you're always under challenge. You're always trying to push and make, more effective vaccines and safer vaccines. And so when we talk about, and I think this is a discussion that, we're touching on, is, you know, even if, say, an aluminium adjuvanted protein vaccine is safe, does that mean we can't improve it?
Right.
Of course not. We can aspire to shave, and sort of make it even safer. Just
Absolutely.
like the airline industry would say that they're not complacent and they haven't said, okay, now there's only one death per whatever million miles travelled. That's fine. I mean, that's so safe. They're always pushing to make it even safer still. And the same with vaccines. We shouldn't ever get complacent and we need to always drive. And that's why, when we are trying to say we should make a better vaccine and maybe we should take alum out of a vaccine and put something else in, um, we're already starting at a very high level, you
Absolutely.
know, like 9.9 second 100 meter.
Absolutely.
And now we're trying to get to 9.8 or 9.7 seconds. Like, we're trying to shave. That's what we're trying to do. And so we don't want the public to get the impression when we have these vigorous debates
Right.
that we're suggesting that, we're doing this because that existing vaccine is unsafe. That is not what we're trying to do.
I
We're
appreciate.
trying to take rare side effects and make them even rarer. And again, that's because we always aspiring to perfection, but of course perfection is an impossibility. But that doesn't mean we shouldn't always be pushing to get closer to perfection. And so that's when we debate inside the vaccine world, that's the debate we're having. We're not saying, my God, these existing vaccines are terrible or they don't work or they're not safe. That is not what we're saying. We're saying we have great vaccines. We want to make them even greater.
Very well said. Dr. Petrosky, briefly about the plant-based vaccine and what does what is the outlook of this platform at the moment?
Well, so plant-based vaccines have been around for quite some time as an idea, and really they're no different. They're recombinant proteins, so synthetic
Right.
proteins. And so you can make synthetic proteins. Initially, people made them in bacterial culture systems. Then they moved to what we call mammalian cell culture systems, more like human cells or animal cells grown in a broth. We ourselves then moved to an insect cell system where we grow insect cells.
Right.
But you can do the same with plant cells, and you can actually put, these genes to make this protein into plants themselves. And mainly this is done in tobacco plants.
Yeah,
Uh,
I
um,
read.
and
Yeah.
and, and that's because genetically they're easy to manipulate and put genes into, and the genome was known a long time ago. So it's got nothing to do with the tobacco industry. It's just using the tobacco plants as a source of making a synthetic protein. So these are all just means to an end. As I say, the outcome is the same. Whether you make your synthetic protein in a plant or an insect cell
Okay.
or a bacterial cell, it ultimately doesn't change the ultimate product, which is the synthetic protein.
Okay.
And so, yes, it has some great advantages. You can obviously grow enormous amounts of plants. That gives you a raw material which has a low cost. Whereas if we're growing large numbers of cells in culture media, that can get quite expensive because you have to feed them, you have to keep them warm. You don't have to do that, with your plants. You can grow them in a greenhouse. So that's the major attraction of using plants, is technically it reduces the cost, although sometimes the cost of that step is only a tiny fraction of the cost of the end product vaccine. And therefore, what looks like a big advantage becomes no advantage. Because if it shaves a few cents off, say, the recombinant protein, but the $10 or $100 of cost of the vaccine is the cost of the clinical trials and the development, which, as you know, is a horrendous part of the cost, is the development. It's not actually the raw materials. Then of course, shaving a few cents off by producing it in plants doesn't really have an impact. And then the question would be, well, does it have any other advantage over making it in insect cells or in other cells? And that's probably why to this day there are no vaccines on the market that are made in plants. In fact, Medicago, which was the closest company, they made a COVID vaccine in plants. They got it into clinical trials,
Right.
but then they actually went into bankruptcy and they don't exist anymore.
Right.
So unfortunately, they were the leader in the area, and the fact they collapsed probably means that we may not see a plant-based vaccine developed, at least for human use, because the investors will always see failure and they don't want to go there again and readdress it. So, and I think that's again because there weren't clear advantages apart from maybe the cost of the recombinant protein. But as I say, that's only one
Fraction.
component of the cost of a vaccine.